Hey, welcome to the first instructional video. Hopefully you've gotten MATLAB up and working, and I'm going to show you how to use that either later today or tomorrow. But before we go, I want to talk about row reduction and echelon forms. Why? Well, because it helps to understand what we're trying to accomplish before we start using MATLAB to do it. Okay? So let's go through this and learn the content and understand what row operations are and how we're going to reduce these matrices to solve them. Okay, so what is echelon form? And this is called REF, or row echelon form. And there are three rules. The first rule is that all non-zero rows are above any rows that are all zeros. So if there are any rows that are all zeros, they have to be at the bottom of the matrix. Okay. And then each leading entry, which is a leading entry, is a non-zero entry furthest to the left, okay? And it has to be in a column to the right of the leading entry in the row above it. Okay, so we get this kind of stair-stepping pattern, right? That the leading entries have to be further and further to the right as we go down the rows, okay? And there have to be all zeros until we have that leading entry, okay? And then the third rule is that all entries in a column below a leading entry are zero. Okay, so that's echelon form, row echelon form. Okay, all non-zero rows are above any rows of all zeros. So again, if we have any zero rows, they go all at the bottom. And the leading entries have to have this stair-step pattern where a leading entry in a row has to be to the right of the leading entry above it. It can't be below it. It has to be to the right, at least one column over. And so as we go down the rows, the leading entries move further and further to the right. And then all the entries below the leading entries are zeros. That's what echelon form is. So let's talk about how we're going to accomplish that, okay? All right, so sometimes we actually want to do two additional steps, and when we go all the way to reduce row echelon form, RREF is going to be our abbreviation for that. What we're going to do, it's going to be helpful in certain situations to be able to go all the way to RREF. It's the same row operations that we use to do REF, but we do two additional steps. We make all the leading entries equal to 1. And then we get zeros above it too, right? So just to have REF form, we have zeros below each leading entry. Then we convert all the leading entries to 1s. And then we get zeros above those leading entries. Okay? All right, so question, are these matrices in row echelon form or reduced row echelon form? Okay, well, let's take a look. So I'm just going to circle the leading entries and notice that each leading entry is in fact in a column to the right of the one above it, right? So we do in fact have the stair-stepping pattern that we're supposed to have. We have zeros below the leading entries, right? So zeros below the leading entries. All right. So this one is in REF form, right? Okay, what about this one? So here's a leading entry, a leading entry, a leading entry. So we do in fact have the stair-step pattern. We have zeros below. Oh, but we also have zeros above the leading entries, and all the leading entries have been converted to 1s. Okay, so this is our REF. Okay. So the extra two steps have been done where we convert the leading entries to 1s and we get zeros in the column above each of the leading entries. Okay. Okay. So it turns out that we have this big, huge result. This will explain why we're talking about reduced row echelon form. Why? Well, because each matrix is row equivalent to one and only one reduced echelon form. So it's somewhat like fractions, right? That if we reduce a fraction to lowest terms, we know that they're equal, right? So if I have two fractions that are different, but they both reduce in lowest terms to 3/4, I know that they're equal to each other. The same thing is true with matrices. If I can row reduce them to REF form, um, then I can tell whether or not they're equal. They're going to have the same solutions, okay? And so when we're reducing to REF, we call those steps Gaussian elimination. And if we go all the way to RREF, okay, it's called Gauss-Jordan elimination. That last name, it looks like Jordan, but his last name was pronounced Jordan. Okay, so Gauss-Jordan elimination. And it's kind of cool. We're basically going to learn how to reduce these matrices, kind of like reducing a fraction to its lowest terms, right? We're going to reduce these matrices to REF so that we can compare and see whether or not they have the same solutions as another matrix, okay? So moving on, let me get rid of these pen marks, okay. So these leading entries, we call them pivots, okay? And in a pivot position, they have this pattern, right? Where the leading entries have to be to the right of the leading entry in the row above it. Okay? So these pivots are non-zero numbers, that it's in a pivot position, and we use them to create zeros below or above, and we can also change them into a leading one as needed. Okay? And we're going to introduce another term here, pivot column, right? Well, a pivot column is a column that contains a leading entry or a pivot position. So you can see there circled in red and gray the three pivots, and therefore we have three pivot columns. Okay, so that's just some language we're going to need as we go. So suppose we're going to use Gaussian elimination and Gauss-Jordan elimination to solve the following system of equations. Okay, so this is something that we will talk about, but what I have is I can think of this as just the numbers, right? So in the first column of my matrix, I'm going to have all the coefficients of the variable x sub 1. And then in the second column, I'm going to have all the coefficients of the variable x sub 2, and so forth. That's going to work. And then I'm going to have a line where the equal sign is, and so that should explain what we're seeing on the next page. Let me get rid of those and jump to the next page. There we go. So we just have the coefficients. All right. This is called an augmented matrix. And we have the pivot position in the first column is going to be a 1. That's nice for us. Okay. And sometimes we are going to have to interchange rows. Again, we wouldn't want the -3 to be the pivot. So if the fourth row and the first row were swapped, we would want to do a row swap to get the 1 back in that pivot position. And we'll learn more about the strategy of this as we go. Okay, so now we're going to use row replacement operations to create zeros in all positions below the pivot. Okay, so what are we going to do first? And let's talk about how those numbers arrive. Okay. So the first row operation we already talked about, I can swap two rows. And if you think about it, that won't change the solution to the system of equations. Just, writing the first equation as the second and the second equation as the first, it's still going to have the same solution. So it turns out that a slightly less obvious one that won't change the solutions of the system of equations is I can add a non-zero multiple of one row to another row. And I can take that sum and replace this row. So let me see if I can explain that just slightly better. Okay, so what I'm going to do is I'm going to take a non-zero multiple of this row, and I'm going to add it to the second row, And that's going to give me the second row of the new matrix. Okay? And it should be clear what I'm going to add, right? I just need to add 1 times the first row. Why? Because 1 times 1 is 1 plus negative 1. That'll give me a 0 here. Okay? And that's what I want, right? The rules say that I want zeros below the pivot. Okay, so I need to get this number changed into a 0, and I'm just going to let whatever happens, happens to the other numbers in the row. Let's go over that quickly and see how that works. Remember, we're adding the first row to the second and putting the answer here. Sorry, there we go. Okay, so let's look at this. The first two numbers, we add the 1 and the negative 1, and we get this 0. Whoa, we have a 2 and a negative 2, and we get a 0. Then we add the negative 1 and the 1, and we also get a 0. So the first 3 entries in the new matrix are zeros. Then we add the 2 plus 2, and we get the 4. And we add 1 and 3, and get another 4. And we add the 2 and the 6 to get the 8. 2 plus 6 is 8. Okay, so what we've done is we've taken 1 times the first row and added it to the second and replaced the second row with that sum. Interesting. Okay. Let's see if we can get rid of the pen marks, because what's going to happen now? Well, what's going to happen now is we need to get rid of, there we go. Here, so this is the original third row of the matrix. What do we need to do? We need to get rid of the 2 and make it a 0. So what are we going to do? Okay, well, I'm going to multiply the top row by negative 2. Why? Well, negative 2 times 1 is negative 2. Negative 2 plus 2 will get me a 0 here. So that's what I'm trying to do. I'm trying to get zeros in the column below that first pivot. Okay, so let me get rid of those. And you can see what happens. Oops, went a little too far there. Okay, so remember, we're doing the negative 2 times the first row plus the second. So take the negative 2 times the 1 plus 2. I do, in fact, get the 0. I take a negative 2 times this 2. I get a negative 4 plus 4. That's also 0. Okay. I'm going to take a negative 2 times the negative 1. That's going to be a positive 2 plus the negative 3. So a negative 1 is the result of that. Okay, negative 2 times the positive 2 is negative 4 plus the 2 is equal to negative 2. Negative 2 times 1 is negative 2 plus 0, so that's just negative 2. And then negative 2 times positive 2 is negative 4 plus the 3 is going to be equal to negative 1, right? We have negative 4 plus 3, so we have negative 1. That's how we're getting the third row. The third row, to get the third row, we replace it with negative 2 times the first row plus the original third row. That's how we get the new third row. Okay, let's get rid of all those marks there. And okay, so this is the original fourth row. What are we going to do here? Well, I think it's clear that we're going to take the pivot and multiply it times positive 3. So we're going to take 3 times the first row and add it to the fourth row. Let's check on that math. There you go. Right, and does it make sense? So remember, we're doing a negative 3. So negative 3 times 1 is negative 3. I'm sorry, I need a positive 3. Dummy. Okay, so positive 3 times 1 plus a negative 3 is in fact 0. 3 times 2 is 6 plus negative 6 is 0. 3 times negative 1 is negative 3 plus 2 is negative 1. 3 times 2 is 6, plus 0 is 6. 3 times 1 is 3, plus 3 is 6. And 3 times 2 is 6, plus 9 is 15. So the fourth row becomes the result when I take 3 times the first row and add it to the original fourth row. That's how I get the new fourth row. Okay, and we've made good progress here, right? So we're looking at we didn't just get zeros below the pivot, we also ended up with zeros in this second column as well. Okay, but now we kind of have this awkward zero here. Okay, and then our candidate pivots, are kind of in this third column here below the -1. So we might have to do something to get things moving along, but we're going to get to REF form pretty quickly here. So let's jump on ahead. So this pivot column, we've got a problem. We've got a 0 in the pivot, okay? And we don't really want a 0 in the pivot. So the first thing we're going to do is we're just going to swap rows 2 and 3. Why? Well, then we'll have a -1 in the pivot. And while that may not be ideal, it's not a 0. And if you think about it, if I have a 0 in the pivot, a 0 can't be a pivot, right? Why? Because there's no way to get rid of these. If I take 3 times the second row here, right? Well, 3 times 0 is 0, so it doesn't actually change anything below it. So multiplying by a non-zero constant gets me something times 0 that equals 0, so it won't change anything in the column below the 0. So I need a non-zero number in that pivot for things to work out. So that's what's going on there. We're just swapping rows 2 and 3, so now we have an actual pivot that we can work with. Okay, and sorry. So now what are we going to do? We are going to, okay, so we've got a pivot, but now we need a 0 down here. Okay, we've got a -1 and we need a 0. So what's going to happen? Well, this is the new matrix we're working with, and we're going to take a -1 times the second row here, and add it to the fourth row. Okay, so -1 times -1 is +1 plus -1, that'll be a 0, and then we'll have +2 plus 6, that'll be an 8, and then a +2 plus a 6 is an 8, and then a 1 plus 15 is 16. Okay, so we're going to have 0, 8, and 16, 0, 8, 8, 16 in this bottom row. Why? Well, we're just doing the row operation where we use this pivot to get a 0 in this position below it in the fourth row. Okay, so let me get rid of that so you can see, and there you go. Right there. Okay, so here is the matrix before we get rid of that -1 in the fourth row, third column, right? And here's the result. And like we said, it is 0, 8, 8, 16, which goes in that column. So now we have 2 pivots, right? We use this pivot, and we have zeros below it. And we got lucky with these zeros. They were a result of doing the first step. Then we used the -1 as a pivot and got zeros below it. So now here's our new pivot column, and what do we need? We need zeros below it. But oh, look at this. Each of the numbers in the fourth column is exactly double the numbers in the third row. Okay, so I said column instead of row. Let me try that again. All of these numbers in the fourth row are exactly double their corresponding entries in the third row. Interesting. Okay, so then what will that mean? Okay, so and the slides, you probably have read this, they're talking about, we end up with a submatrix, and I can do all the same steps to the submatrix. And the point is that I can kind of ignore everything but the 6 numbers here that I'm working on in the bottom right-hand corner of the matrix, right? Because nothing is affecting these entries up here. Once I get the zeros below the pivots, right, I'm kind of done with all of the matrix except the bottom right-hand corner. So that's what all this tough stuff is about, cover or ignore. the parts of the matrix that I'm not worried about, okay? But I do the same steps to the submatrix that remains. Okay, let's get rid of all that stupid ink. All right, and what happens here first? So this is the third row operation. So what are the first two? The first row operation is I can switch any two rows that I need to, and we saw that. We switched rows 2 and 3. The second row operation is I can replace a row with a non-zero multiple of another row plus it. And then the third row operation is I can multiply through by a non-zero constant. Okay, a non-zero constant. That's what's going on here. We're just going to multiply through the third row times 1/4. And 1/4 times 4 is 1. And 1/4 times 4 is 1. And 1/4 times 8 is 2. So that's what's happening here. Okay, but what's happening down here? Well, what we're doing now, right, if you look at the bottom right-hand corner over here, they're saying, look, all I have to do is multiply this third row times -8 and add it to the fourth row. Okay, so -8 times 1 plus 8, that's 0. So there you see that one. -8, and we have another one that works just like that. -8 plus 8 is 0. And then -8 times 2 is -16 plus the 16. That also equals 0. So we get kind of lucky here. As we work on getting zeros below this pivot, we actually get all zeros. And so it turns out that now we're done. We're actually in row echelon form. And if we wanted to, we could very easily be in reduced row echelon form. How? Well, we just would have to change this from a -1 to a +1, and I can do that by multiplying through by -1. Okay, so this is in REF currently, but I'm not very far from RREF. So I'm in row echelon form, but I could be in reduced row echelon form pretty easily, although I guess I would also need to get some zeros above my pivots if I wanted to be in RREF. But we're very close. We're very close, and we're doing well. So let's go forward here. And again, they're making the point in this PowerPoint, right, that the 4 becomes the 1, right? And then the third row, I showed you how we changed that into how we changed the fourth row from 8, 8, 16, how we got the 0, 0, 0. That was by multiplying the third row by -8 and adding it to the fourth row and replacing the fourth row with the result. Okay, this is going really well. And so they're talking about what are we going to do? Okay, so the first thing we do here is we get some zeros, okay? So we're going all the way to RREF, and what happens? Well, these entries need to become zeros. Okay, so what's happened there? All right, let's talk about that. What row operations can accomplish that? Well, okay, I can use this pivot to get the -2 equal to 0. What do? I need to multiply the third row times -2, add it to the second. Okay, so let's do that. So -2 times 1, I'm sorry, it's going to be +2. I did this again. I take +2 times 1, that's 2, plus -2, and that gives me a 0. By the way, the +2 times the 0, 0, 0 adds nothing, so there's no changes that happen to the first 3 entries of row 2. Okay, but +2 times 1 gives me another +2 plus the -2. That gives me another 0. And then 2 times 2 is 4, minus 1 is 3. Okay, so we have just used the pivot in the third row to get zeros in the column above that pivot. Okay, and what's next here? Okay, what's going on? Well, notice the only thing that changes, and it actually takes a second. I had to pause the video and look to see what had changed. What had changed is in the second row, right? This 1 has become positive. Okay, so it went from a -1 to a +1, and notice that the 3 has become negative. So what do? We multiplied through in, oh, sorry, wrong row. We had multiplied through in the second row by a -1. And so -1 times -1 is +1, and -1 times +3 is -3. So yeah, we're making progress here. And what's happening in the fourth step? Well, let's take a look. I've got 1s in all my pivot positions. I have 0s in the columns, in the pivot columns below each pivot, all 0s. Then I don't just have leading entries, I have 1s. So that was the fourth thing that we needed. And then I need 0s above all of my pivots. And there aren't any entries above the first pivot. So it's just these, the third and fourth columns here. And now this is in reduced row echelon form. Okay, except this entry right here needs to become, wait, I'm sorry, this entry is above a pivot. It needs to become 0. How do we do that? Well, we take the second row and add it to the first. Okay, so when I do 1 plus 0, I get this 1. And I do 2 plus 0, and I get this 2. And 0 plus 0 is 0. And -1 plus 0 I'm sorry. What did I do? Yeah, right. We got the 0 here, and the 0 here is 0 plus 0, and the -1 plus 0 is -1, and the -2 plus -3 is equal to -5. Okay, so the fourth matrix, the matrix there in the bottom right, it is in fact in reduced row echelon form. Now that we've gotten rid of that last -1, the -1 in the first row, third column. So now that we're in reduced row echelon form, let me talk about this. So go back to the simplified fraction, the fraction in lowest terms. So this was our original matrix. Well, it's where our original matrix came from. It's the original system of equations. And we created the coefficient matrix, the augmented coefficient matrix, and we row reduced it. And this is the row reduced echelon form, and we put the variables back in. We put it back into, a system of equations form. But the cool thing is I've taken the first one and reduced it to the second one. But when you do those 3 row operations, none of those steps changes the solution of the system of equations. So I've reduced to lowest terms. Basically, I still have a matrix, this augmented matrix, if I make the augmented matrix, but this system, the second system of equations, has the same solution as the first. But oh my gosh, it is a whole lot easier to solve. Okay, and even though we start in the top right, top left, and kind of work our way diagonally down. When we're row reducing, we kind of go the opposite way when we're solving, and we start in the bottom right and work back up. So let's see how that looks on the next slide. Okay, so just quickly, these variables that go with the leading coefficients, the pivots, are called basic variables. Okay, so basic variables, and all the other ones are called free. Okay, so in this case, it's x sub 2 and x sub 5. All right. Okay, so basic variables and free variables. And and with the free variables, that's where we end up with lots of different possibilities. There can be, because each new choice of a free variable leads to another thing that will, another solution set that will actually be a solution. Okay. So how can we describe the solution set for these systems? Well, this one's easy, right? Okay. X sub 3 has to equal -3. But we have a free variable in the others. Okay, so for each basic variable, we solve in terms of the free variables. Okay, so basically all we've done is we've taken the top equation and we've solved it for x sub 1. So that means I'm going to have a -5, and then when I move the negative x sub 5 over here, it'll be positive. When I take the positive 2x over here, it'll be negative. So that's what you're seeing here. And to solve for x sub 4, all we had to do was subtract x sub 5 from both sides. So I have a negative x sub 5 over here. All right, so we solved for all of the basic variables in terms of just numbers and the free variables. Okay. And then what? Well, so now we know what each of the variables is supposed to be. We know that x2 is free and x5 is free. They can be any numbers you want to put in. Any real numbers can go in there. And then once you know what x2 and x5 are, you can plug them in and figure out what x sub 1 and x sub 4 are. And we already knew that x sub 3 had to be equal to 3. Okay, so that's how row reducing goes. And that's what we're going to learn. We're going to spend all of this week on row reducing, going through it in MATLAB, showing you how to do it. We're just going to do lots and lots of examples. Now, quickly let me recap. There are 3 row operations that we can use. I can swap any 2 rows. I can multiply through a single row by any non-zero constant. And I can replace a row with the result when I multiply a different row by a non-zero constant and add it to that row. Okay, so those are the 3 row operations I'm allowed to do. As long as I do those row operations and only those row operations, I won't change the solution set. So I can simplify the matrices with row operations and then solve the simpler matrices and know that I have the correct solution to the more complicated matrix. Okay, and that's what we're going to practice doing. And we're going to do it in MATLAB, and we're going to do it over and over. So hopefully, I'm going to post this PowerPoint online so you can learn the vocabulary and go through. But as this example shows, we're going to do the same thing every time. There's a very consistent pattern of steps that we're going to use to solve these. All right. Have a great afternoon, and I'll be back later with the examples in MATLAB of how to do row operations, how to simplify these matrices and solve them.